In part one of the videos, we talked about the different kind of bonds, ionic covalent and polar covalent, and we left off here with an example of hydrogen chloride. Hydrogen chloride is HCl. Chlorine's electronegativity is greater than hydrogen, so chlorine will pull electrons more tightly. So this symbol here means it's kind of negative because it has more electrons more often than hydrogen does, kind of positive on the hydrogen end. All right, so this polar covalent bond between them makes the molecule, we can use that term, itself have ends that are different from each other. We have a special name for that. We call that polarity. Right, and so a dipole is any kind of molecule that has two distinct different ends. They have to have some quality that is opposite to be a dipole, meaning two poles. Kind of a redundant because you can't be polar if you don't have two. There's no such thing as a monopole, at least so far we don't know of any. So there have to be polar covalent bonds, and then there has to be an asymmetrical structure to the molecule. So one end of it has to be kind of positive, one end has to be kind of negative. So an example of that is water. Here's a ball and stick structure for water. Water has the oxygen with two hydrogens. It is this bent shape. So the oxygen, it has a high electronegativity, pulls electrons more tightly toward it than on the hydrogen side. So this side of the water molecule is positive, and this side of the water molecule is negative, so we say water is a dipole. This side's one pole, and this side is the other pole, so it is a dipole, or we can just say it's a polar molecule. It has both criteria. These bonds are polar because oxygen is higher in electronegativity than hydrogen is, and because it's asymmetrical to a line going this way. It has a positive side, a partially positive side, and a partially negative side. All right, so there is this physics term, really, for something which is a dipole. It has a thing called a dipole moment, and the dipole moment, it tells us how it's going to behave. And in the case of water, if it wasn't for water being a dipole, water would not have the characteristics and the properties that make it useful to us. It would not be a liquid at room temperature, for example. It would be a gas at room temperature. Also, it wouldn't dissolve things easily. We wouldn't be able to make things like Kool-Aid if it wasn't for the fact that water is a dipole. So the polar nature of water is essential to our lives because we are composed mostly of water, and the things that water does for us are as a result are a result of its polarity. Okay, so that's it for polarity, and in the next part of the video we will move on toward looking at ions.